Okay, now so let's look at how to find standard deviation, the main topic of discussion in 3.3. So, as a notation, standard deviation, we're using the lowercase letter s for standard deviation. Okay, so in this discussion here, instead of looking at the formula first, we are going to go directly into a problem first by finding a standard deviation. And then after we finish the standard deviation, we are going to derive the formula. We are going to give the finalized formula. And so why don't we pick a small data set? So this time we are looking at data set 4. And then the goal now is to find standard deviation. Okay. So now, before we can find standard deviation, keep in mind we always need to have the mean value ready for it before you attempt to find the standard deviation. So the mean value for this data set 4 is going to be, rounding to 2 decimal places, is going to be 6.27. And so that is the mean value for data set 4. To find the standard deviation, here's what we do. And make sure you watch my order of operations carefully, because that's how we set up the problem before we can actually finish in finding the final value, numerical value for standard deviation. So what I need to do is I'm going to go through my data set for every single point by point. Each point, say the first data value is a 2 on my data set. I'm going to subtract the mean, 6.27. And so after subtractions, you're going to need to square that difference. And then there's only one data value 2, so I'm leaving that sum, that square of the difference, the same. And then I'm going to look over to the next data item, the next data value on the list, the next distinct data value on the list, and that would be 3. I'm going to subtract again the mean value, 6.27, and then that same difference, that similar difference, I'm going to square that difference. And this time, how many 3s do I have? I have two data value 3 on my list. So I'm going to multiply that difference here by 2. That square of difference by 2, and now I'm adding that to the previous square to the preceding square of difference. And so now you can see that I'm going to keep doing the same way until I run out of the list, run out of the data. So my next data item is a 4, taking away the mean value, and that's difference. I'm going to square it, and there's only one 4, so I don't have to worry about multiply with any number in front. Now make sure when you multiply with the number in front, the number is multiplied in front of the square, not in front of the number. And so here in my next data item, I have a 6 and minus 6.27, which is the mean value again, all square. So the point now is that I need to finish each square here. I need to finish each square of difference from each data value to the mean value, and then keep adding up the sums. Keep adding up. So the next one here would be 7 minus 6.27 all square. And I'm running out of space, so I'm going to have to write in a little bit in the line in the bottom here. The next item, I'm going to have 8 minus 6.27, square the difference. But now this time I'm going to have 3 different square of differences like that, because I have 3 different number 8s. And the last one is going to be 10 minus 6.27. Take the square, and there are 2 10s, so that's just, so of course I'm going to have 2 of the square difference like this, so 2 times. And now all that, after finish adding, now we are going to divide all that here by a total of, now my data set here contain 11 pieces of data, so you're gonna have to divide by 11 minus 1 in the bottom actually, so you actually divide by 10. And now in the end, once you finish dividing, then we take square root. So you can see that I intentionally put my order of operations here in order, so that you can see that which operation need to be performed first, and then we can rely on that guiding line to finally compute the standard deviation value. So now let me demonstrate to you how you can, and how much that standard deviation value is. So now on my calculator, the first value, the first squares of difference is 2 minus 6.27, and we square that difference. Okay, and we adding that to the next square of difference, 3 minus 6.27, and we square that difference again, and here's the notation for square. And then make sure we multiply that by 2. And then the next data item I'm going to add again, and then I need to subtract the mean value from 4 and square the difference again. And the next data item, I have 6 minus 6.27, and I'm going to square that difference again. And then the next data item, so now I'm going to have in parentheses 7 minus 6.27, square the difference, plus again, and I have another difference, 3, no, wait, wrong one, 8 minus 6.27, square the difference, and now there are 3 times, so I'm going to multiply that by 3, plus, and the last one, 10 minus 6.27, square the difference, and there are 2 times. And so that is the total after I add all the possible squares of difference. But now this is not my standard deviation. Now once I get that number 82.18, I'm going to divide all that here by 10, and remember, 1 less than the total number of data. So we divide that by 10, I have 8.21. So now the final answer, the current answer here, I am gonna finally take the square root. So you're gonna go square root of the answer. Whoops. So we have to do it again. So square root, and now I have 88.21819. Close the square root, and there is your standard deviation, the value for standard deviation. So 2.8667 and 83 and whatsoever. So now a lot of time we conventionally keep the standard deviations in 2 decimal places. So my finalized, calculated, evaluated standard deviation value is 2.87 actually. So rounding properly is to make it 2.87. So that is the value of my standard deviation. So now, after finishing one problem in finding an actual standard deviation for dataset 4, let's now draw a finalized formula for standard deviation. So in general, standard deviation can be found by taking the difference from each dataset value, from each data value, from the mean. So I'm going to use x1, x2, x3, and so on to represent each individual distinct data. And so here, x1 is my first individual data, distinct data. I'm going to subtract the mean value from it and square the difference. And then maybe if there's some kind of frequency, I'm going to multiply that frequency in front. And I'm going to move on to the next distinct data, x2, and subtract the mean from it, square the difference, multiply with the frequency, f2, and then I keep doing this for the rest of my data values on the list until I reach to the last distinct data value, and that might be the x sub r item, and subtract the mean value, square the difference, multiply with the frequency, and now once again we keep adding each of those squares of the difference together, and once we finish adding the squares of the difference, now we're going to divide by the total n minus 1, and keep in mind n here represents the total number of data points, data values on the list, and so n minus 1 is what we divide. It's a formula to remember. And now once you finish dividing, now we take the square root, and that is our finalized formula to find standard deviation.